Hello. Hi, Kari. Okay, good evening. This is our August week 4. Yes, I'm good. How are you? So this is the last week of August before we head for our holiday next week. Okay, you do know next week is holiday, huh? You do know next week is holiday, huh? So I am not going into a new chapter today because next week is holiday. So we have nothing much to talk about actually. Okay, besides the fact that we have to go back to chapter 7. Do you have chapter 7 with you? Do you have chapter 7 with you? You do, huh? You do, huh? Okay, we have to jump like one chapter back. I'm sorry because we have thoroughly done chapter 8. So there's nothing we can do there. Okay, so let's go to our chapter 7. Okay, let's do some exercise here while we, wait for chapter 9. Okay, when our holiday resumes, okay, we will go for chapter 9 lah. But for now, there's no need to. Okay, so let's go to question. Where have we done? Okay, I think we have done question 7. Okay, have we done question 8? Page 14. Have we done question 8? No. Okay, so you can try question 8 first. Okay, I'm gonna let you do some work here. Okay, question 8. Have we done question 11B? This part here, 11B? No? Okay, you can try question 11B. Besides A lah, Okay, question 11. Question 11. And hang on, question 11. Just now was 8, now 11. 12, if you remember. And 13. Yeah, I think that would be it. Okay, so yeah, you can try 15 too. Yeah, I know it's almost a similar question, but since we're at it, might as well we do it. Okay, so 11, 12. Okay, you start from 11, I would say. Start from 11. Start from 11. We can ignore 8 because I don't think concave is important. Okay, you can start from 11. 11B here. Page 17 here. So 11B. Okay, so 11, 12, 13, 15. 4 questions here. I will give you, is 25 minutes enough? Is 25 minutes enough? You can refer to the notes first. Okay, and I'll be right back at after 25 minutes. Okay, to discuss this. Okay, so I'll leave it up to this and I'll come back later. Okay, so see you soon. Okay, so Kavi, you're done. So we can discuss. Is that it? Okay, if that's the case, then let's begin with B. Okay, so this is the object, right? So the lens near the object is the objective lens. Okay, and then this is your eye. So this is your eyepiece lens. You wanna call it an eyepiece or eyepiece lens, both are fine. Okay, so same goes to here, eyepiece. Same goes to here, objective lens. All right, you okay with this? Okay, cool. Right, and as I said, this is microscope, right? So microscope for the objective lens, the focal length needs to be short. Because I'm viewing a near object, so my focal length needs to be short. If I'm viewing a far object, my focal length needs to be long. You see, makes sense, right? I want to see something near, of course, my lens length need to be short, near short. If I want to see something far, my lens need to be long. Okay, so my lens need to be thick. Okay, my lens need to be thick, and this lens need to be thin. Okay, and as I said before, for microscope, FO and FE, they cannot touch. Okay, FO and FE, they cannot touch. Right, FO is the focal length of objective lens. FE is the focal length for eyepiece. So both focal lengths cannot touch. Okay, if they touch, you don't see anything. Okay, this is what you need to memorize. Okay, you don't need to learn to draw, Kavi. Don't learn how to draw. There's no need to learn how to draw. You just need to know a few points about them. Okay, so the eyepiece and the objective lens are convex lens. Of course, it's convex. We don't use concave. Okay, concave is only for one, which is for short-sightedness. That's all. Concave lens is useless because they cannot bend, they cannot focus slide, so we don't use them. Okay, so the focal length of the objective lens is shorter. Like I said, here it's short, here it's long. Just looking at the diagram, you will know. Okay, shorter. So the magnifying power is the product. Okay, what does it mean? Product means times, quotient means divide. Okay, for microscope, okay, this thing I kind of skipped it last time because I don't think it's important. But if you want to know, here comes, right? How do you know how many times does it multiply? How does it magnify? You just multiply by the magnifying power of each lens. If objective lens can magnify 4 times, eyepiece can magnify 40 times, so you times together is 160 times. Okay, so it's the product. Okay, characteristic formed by the microscope. So what is this image like? Of course, it is virtual because you cannot put it on a screen. It will be very magnified, and of course, it is inverted. Okay, don't focus on this because you actually have 2 characteristics here. Can you see there's one image here? This image is this, and I use this image as the object. I make another image here. So there's 2 here. Virtual means cannot be put on the screen. Kavi, if you remember, real means there's something on the screen, like a projector. Projector is real. Virtual is like your magnifying glass. You see, magnifying glass has nothing on the screen, right? Okay, so I'm not going to focus on this. Okay, because there's 2 sets to memorize. Okay, so next, let's look at telescope. Telescope, same thing. The object is from very far. So this is the objective lens. Okay, this is the eyepiece. Same thing here. Look, wait. Yeah, what's up? Where is the object? Oh, the object is very far. It's very far. If I'm viewing a planet, do you think my planet is here? You get what I mean? You get what I mean? If I'm viewing Mars, Mars is from very far, like infinity far. You get me? So that's why the object, the light comes in parallel because it's very far. Object from infinity. Okay, I mean it's not exactly infinity lah, but it's very far. We consider it as infinity. Okay, so now is the reverse. Now is the reverse. This focal length needs to be long. This focal length needs to be short. Just now, okay, everything depends on the objective lens because I'm looking at the object. You see, I'm viewing a near object, so short focal length. I'm viewing a far object, so long focal length. So the other guy must be the reverse. Okay, so we are using convex as well. Okay, it must be longer. Wait, Oh, you look at how sneaky they are. They put eyepiece here. Okay, so the eyepiece must be shorter. Just now they put objective lens. Oh, so sneaky, you see? I almost got tricked there. So they put eyepiece in front. So you see, read the question properly. Okay, so the image, you can say it's I don't know which image they want. I don't know what they want, this or this. Actually, in physics, they learn image characteristic for this too. So you know what? We skip this. We skip this because it doesn't apply here. Okay, it doesn't really apply here. Eyepiece is shorter. Yeah, there. You see? Can you see the eyepiece is very short? Can you see the objective lens is very long? Oh, and FO and FE must touch. Okay, FO and FE must touch. Just now cannot touch. Now must touch. For telescope must touch. If no touching means you don't see anything. Okay, so what do we see? What do we use this for? We use this for stars, for planets. Okay, so next, number 12. This is as you can see, small become big. Obviously, this guy is a microscope. Okay, this is a microscope. Yeah, sure. Okay, then. Okay, the function of the optical instrument. No, it's, you see, how can telescope be, the object be this small? Does it make sense? Sorry, my iPad screen is acting a bit weird here. Let me reset. Okay, the function of telescope. Sorry, a microscope. What is the function of a microscope? It is to magnify a tiny object. Okay, the point is to magnify, but not just to magnify an object, is to magnify a tiny object because I'm looking at a bacteria. Right? So state lens P and Q. So you know lah, P is the objective lens. Okay, and Q is the eyepiece. Some books they say eyepiece lens, but whatever lah, it's the same lah. Okay, explain briefly the use of lens P. Okay, what is the function of lens P? Lens P is to make this object a real image. Can you see? Because imagine this is a screen. I'm making this object forming an image on the opposite. That means there's something on the screen. Okay, so this is to form a real magnified image. Okay, it's magnified, you see? I'm making this small one bigger so that later this one will make it even bigger. Okay, I'm making a real magnified image. Okay, a real magnified image. Can? Easy. Like I said, real is, okay, can we just think of this? You go to cinema, you see something real. Cinema has a screen, right? Cinema has a screen, right? You go cinema, you see something real. Okay? And then, yeah, basically virtual means nothing on the screen. Okay? So 13. Distant objects such as the stars, the focal length of FO objective is 40. I see telescope FO is longer. Can you see? FO is longer. FE is shorter. Can see, can see, so FE is 5. Okay, so name the instrument. This is a telescope, of course. why the diameter of objective lens is larger than the eyepiece lens. Okay, why is it so? Because this is to view a distant object. Okay, they shouldn't ask this question because that's how they work, right? Why must one be longer than the other? Because that's how they work, right? What's the function of the eyepiece lens? Okay, the eyepiece lens, as you can see here, the eyepiece lens is to amplify this image again. You know what? We skip this question. We skip this because this is not important. Okay, calculate the enlargement. Okay, so for telescope, how do we calculate? Okay, for microscope, just now we multiply, right? But for telescope, now we divide. Why divide? Because we're actually making something smaller. We are making the planet smaller. Because you see, Mars is very big. We don't want to amplify it. We want to make it smaller. Okay, so FO divided by FE. So FO 40 divided by FE 5. Yes, you get 8. Okay, 8 times, 8 times. So I'm making the planet 8 times bigger. Not too much, okay? I want to see something far and I want to slightly amplify it, slightly magnify it. What I keep saying, amplify. I want to slightly magnify it, so 8 times is just nice. Okay, what will happen when the position of the objective lens and eyepiece are exchanged? Okay, you can see it turns into a microscope. Okay, because now I reverse scan the lens already, so now I become a microscope. Can you understand? Can you understand? So telescope and microscope, they're just reverse. It's just reverse setup. It's the same thing. Okay, so can we do 14? I know you didn't do 14, but since it's here, we might as well discuss it. Okay, by the way, this is a camera. Okay, let's just assume this is a DSLR. DSLR are those professional camera. Okay, so DSLR, basically it has a mirror in front. Okay, the image will come here, will bounce to the top. Okay, this is the top view, but they will bounce to the top and then they bounce to your eye. Okay, so when you are confirmed, you press the button, the mirror will flip up, and then the sensor here will capture the image, whatever you see on the mirror just now. I let the sensor capture and I'll save it to the memory card. Okay, and then the mirror will come back down. That's why you hear the tick tock. Okay, the camera tick tock sound is we call it the shutter sound. You get what I'm trying to say here? Do you understand what I'm trying to say here? It works like this, you see? Okay, object, the object come here, bounce up and bounce here. So your eyes is here. So when you're confirmed, this thing will go tick tock, up, down. See the mirror here? See the mirror here? It will go up, down, tick tock, and then the sensor will capture and I will save it. So that's why we call it a DSLR. Okay, it's called DSLR. Okay, so draw a suitable lens in box X. Of course, this needs to be a convex. We don't use concave, right? State the characteristic of the image by the lens. Okay, so this is a camera. Camera is to make something smaller. Of course, it's diminished. Of course, it's real because there's something on the screen. This is a screen. And of course, it's inverted. Okay, the picture you take is actually reversed, just like the diagram we draw here. Remember, this is a camera. Okay, I make my object smaller and it's reversed. No, it's not upright, but the computer in your camera will flip it up. It's just like our eyes. Our eye works the same way. The image in your eye is reversed, but our brain flips it upside down again so that you see something upright. Okay, but the image is actually inverted. Do you get what I mean? Do you get what I mean? Because camera works like this. Camera works like this. Okay, so each part labeled P, Q, R, X, Y has the same function as the retina. You know where's the retina? Retina is the part that detects the light, right? That's the sensor of our eye. So which part is the sensor? Which is Y. Okay, retina will capture light, sensor will capture light, so they function the same way. Okay, so C, based on the part labeled Q. There's another lens here, I think. Oh, no. This, sorry. I think this is the gate here. Oh, okay, I understand now. Okay, this is the gate here. This thing will control the light entering the camera. So they can either make it smaller or make it bigger, just like our pupil, our iris. Remember? You remember what's the iris? So Q is called the diaphragm. What's the function? Is to control or you can say we control the aperture. What's the aperture? Aperture is this opening here. Okay, control the aperture. You see, diaphragm controls the aperture, just like iris control our pupil. Pupil is the hole. Pupil is the hole, the black hole in the middle. Iris is that colorful part. You know, Mark Saleh one is like blue. That's the iris. Okay, so iris will control the pupil. Okay, when you go into a very bright room, your iris will shrink and your pupil will become smaller. This is to protect your eyes. Same goes to camera. When you are going to a very bright condition, you will make your aperture smaller so that your photograph doesn't overexpose. If your photograph is overexposed, your picture is going to look freaking terrible because it's all white. You understand? You understand? And when you enter a dark room, your iris will relax and your pupil will widen. And then in the dark, if you go into a very dark room, 5 seconds later, you can start to see things around you. Right? So camera is the same way. So when you go into a dark place, you need to widen your aperture so that you can take picture in the dark. If not, you cannot see anything. We call it underexposed. Okay, both are bad cases. Overexposed and underexposed, your photograph will look terrible. Right? It will look not professional. Okay, so that's why you hire a professional photographer, because they will not do this mistake. Okay, so next you build a telescope. You have 2 lenses and 2 concave. Okay, we don't use concave. They can go away, right? The larger lenses have 80 cm. The small one has 20. Underline the correct answer. Okay, telescope, we are seeing something far, so the eyepiece must be short. Objective lens must be long. Yeah, it won't look like a pig. I mean, it will just look terrible. Okay, so B, which lens should you use and how far should you place them? We should use convex. How far should you place them? Okay, for telescope, they must touch, right? They must touch. Okay, so the length between 2 lenses should be FO plus FE. That means they must touch. FO plus FE. They must be exactly that length to see, right? But if it's for microscope, it must be larger than FO plus FE. Must be bigger than that. The distance between the lens. Okay, so a small telescope has an objective lens focal length 140, eyepiece with 5. What's the magnifying power? So 140 divided by 5, 28 times. Okay, microscope cannot touch, yes. That's why it must be larger. If it's larger than FO and FE, that means they are separated. You get what I mean? Okay, so Kavi, are you cool with this? Are you cool with this? Right, we are going a bit too fast. That's why we have to reverse back to chapter 7. So sorry, right? But next week, right? Next week, September week 1, we will go to chapter 9. And chapter 9 is really easy. I can finish that in 2 weeks at most. Because it's about what's it again? It's about satellite. The 5 types of satellite. That's all. Okay, it's a really easy chapter. Okay. Okay. So yeah, we are towards the end already. Like I said, if you can handle chapter 5 and 6, nothing is more difficult. Okay, nothing is difficult. Okay, so I hope you're okay with this, huh? I hope you're okay with this. So I think there's nothing else for me to say. Do you want to ask anything before you head for your holiday? I heard the SPM schedule is out, huh? I heard the SPM schedule is out, huh? And this time it sucks because Chinese New Year is right in the middle, right? You start at around, when was it? When do you start again? It's like the beginning of February, right? Wait, what? Fifth one? Oh, experiment. I see. I see. I see. Okay. So okay. So when's the real paper? When's BM? I think it's like end of January or something, right? And then 10th of February is Chinese New Year. So it's like, I think you, if I'm not mistaken, you're having all your teras, your core subject before Chinese New Year, and then after Chinese New Year is gonna be the elective ones. Okay. Yeah, you should feel nervous. That's a good thing. If you feel nervous, that means you care. That's a good thing. Okay. Our students will tell me, so I don't feel anything. Then I'm like, oh, die lah, like that. You don't feel anything. I cannot force you. I look so sad. Why do you say so? Do I look sad? Do I look sad? Lately my mentally is not. I'm not very well. I would say that my mentally. I'm dealing with some issues lah. But yeah, I'm okay. I'm okay. I'm okay. I'm okay for now. I'm okay for now. Thanks for asking. Thanks for noticing. Right. Yeah, we all have some personal stuff we have to deal with, right? Time to time. So yeah. Okay. Yeah, good things. Yeah, I agree, Kavi, I agree. Okay. So I really need this holiday to relax and chill myself. One of it is because I'm overworked. Okay. Oh, really? So you feel better now? You got to the other end of the tunnel? That's good to know, Kavi. That's good to know. That's good to know. Okay, ups and downs, lah. Okay, such is life, lah, right? Okay. Okay, that's good. That's good. Keep the good vibe going on, Kavi. I'm happy for you. I'm happy for you. Yeah, I know this is form 2. It's been a really long time. Okay, so enjoy your holiday. Enjoy your holiday because I will too. Okay, I will see you on the 6th of September. Thank you, thank you for encouraging you. Damn, that's coming for that's really sweet, Kavi. Okay, I appreciate a lot. Okay, I'll see you. Okay, so take care. Happy holidays and bye bye.